Here we're going to take a look at graphing linear inequalities, and then there'll be a separate video about the systems of linear inequalities. So graphing a linear inequality is very similar to just graphing an equation in the form of y equals mx plus b, where b is the y-intercept, and then m is your slope. So we graph it the same way. The difference comes in when you have an inequality like less than or greater than or less than or equal to or greater than or equal to. Like the difference is going to come into there with the line, and then there's some shading that has to happen to identify the solutions, because with inequalities, x like the solution side could take on more values than just a single point or a single part. So it could take on a lot more values, so there are some solutions that we have to highlight. So let's just go ahead and start graphing here. So graphing the inequality x plus y is less than 6. So we want to get it into the form of y equals mx plus b just to allow us to graph. So I'm going to subtract x from both sides. So we get y is less than negative x plus 6. And then I'm going to graph that. So my y-intercept is 6. And my slope is negative 1 over 1, which means we go down 1 to the right 1. So from here, I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And then don't connect the points like right away. And then you want to, with inequalities, you want to try to go both directions. So up 1, up 1, up, left 1. So let's talk about the line that we could create. So since we have less than or greater than, so just a strictly less than or strictly greater than, so one of these inequalities here, so less than, greater than. In these scenarios, we want to use a dotted line. If it was less than or equal to, or greater than or equal to, that means we're going to use a solid line. So in my scenario here, where I have y is less than negative x plus 6, that is going to be a dotted line. Now we want to find the solutions, because we're looking at ordered pairs here. So we want to identify, well, what ordered pairs are going to make it true? Is it going to be ordered pairs down here that makes this a true inequality? Is there going to be ordered pairs up here that's going to make this a true inequality? Like, what ordered pairs would I find? Because we could have more than one ordered pair in an inequality. All we're looking for is ordered pairs to make this statement true. So what we want to do is we want to grab a test point. And there are, you can do this without grabbing a test point. You could do this by just looking at the inequality, but starting off, until you really get familiar with the shading and how that works with the inequalities, I would just use test points. So we're going to take a test point, and this test point is just going to be a point that will determine, if we get a true or false statement, if that point will be a solution or not. So let's just grab a test point. If 0, 0 is available, meaning it's not on the line, then let's just use 0, 0. So I'm going to use the point 0, 0. So this is my x, this is my y. I'm going to take that and plug it into the inequality. So 0 is less than negative 0 plus 6, which is 0 is less than 0 plus 6. 0 is less than 0 plus 6 is 6. So 0 is less than 6. Since 0 is less than 6, that is a true statement. Since my test point was true, then that means I'm going to shade the side with my my test point. So I'm going to shade underneath my line. I'm shading the side. See my test point that was right here. I grabbed the point 0, 0. 0, 0 was right in here. So since that was true, then that means my solutions are below the line. And I'm going to highlight just this. So I'm just going to quickly kind of highlight that. So then any point in my highlighted region here is going to be true. So any ordered pair would make that a true statement. If my test point didn't work, then I'd want to shade the side that does not have the test point. So I'd want to shade this side, but since my test point worked, it became a true statement, I'm shading the side with the test point. So it would just be all of this would be shaded as our solution here. Let's go to the next one. So next one we have 3x minus y is greater than or equal to 2. So let's just solve for y. Let's just get it into that form. Y equals mx plus b. I'm going to subtract 3x. I get negative y is greater than or equal to negative 3x plus 2. Solve for y. I'm going to divide by negative 1. when I divide by -1, since I'm dividing by a negative, my inequality flips. So it's going to be less than or equal to -3x divided by -1 is positive 3x. 2 divided by -1 is -2. And then we graph that, so y-intercept is -2. My slope is 3 over 1, which means we're going to go up 3 to the right 1. So up 3, 1, 2, 3, right 1. Up 3, 1, 2, 3, right 1. 1, 2, 3, right 1. And we can go down 3 to the left 1. Down 3 to the left 1. What do we want? Solid or dotted line? We have the inequality is less than or equal to, so that's going to be a solid line because it is including or equal to. So we're going to include that. So I'm going to connect that. I'm way off. There we go. Not too bad. Grab a test point. Test point is any point not on the line, and since 0, 0 is not on the line, I'm going to test 0, 0. 0, 0 is just always a good test point as long as it's not on the line because it's just 0, 0. You could plug in 0 very easily and figure that out quickly. So 0 is less than or equal to 3 times 0 minus 2. I'm just using this inequality here. So 0 less than or equal to 0 minus 2. 0 less than or equal to 0 minus 2 is -2. 0 less than or equal to -2, that is a false statement. 0 is greater than -2, so since that is a false statement, I am not highlighting the side with 0, 0. I'm highlighting the other side because 0, 0 didn't work, so then that means I have to highlight the side that does not have 0, 0. And if that doesn't make sense to you, if that's like, well, I don't quite understand that, grab an ordered pair from this side of the line, the side that I just highlighted. Like grab 2, 0, plug it into the inequality, see what you get. If you plug in 2, 0, you'll get a true statement. So then that means like, oh, I got a true statement with 2, 0 because 2, 0 was right in here. Kind of hard to see, but right in here. So that means I got a true statement. So then I'm going to highlight the same side of that. And there we go. Now I'm not doing this super precisely, but you get the idea. We're just highlighting that side with that's not 0, 0 because 0, 0 failed. 0, 0 did not work out. So we've got a couple more. Graphing x is greater than 3y. So I'm going to rewrite this just so I can have this flipped around. I'm going to divide by 3 to get y by itself. So y is less than x over 3. The y-intercept is 0 because we don't have like a +5 or -7 or anything like that. So the y-intercept is 0. So I'm going to put a point at 0, 0, 0. My slope is 1 over 3. So up 1 over 3. So up 1 to the right 3. So up 1, right 3, up 1, right 3, or down 1, left 3, down 1, left 3. And then we're using a dotted line because it is strictly less than. So we have to use a dotted line. Next, we have to grab a test point. But now here, since 0, 0 is on the line, I can't use 0, 0. I have to use something else. And there is no right or wrong. Just grab something that's not on the line. I'm going to go with 0, 1. So I'm going to test this point right here, 0, 1. It's not on the line, so that's okay. So I'm going to test 0, 1. So my y value is 1 less than 0 divided by 3. Just going with this right here. So 1 is less than 0. 0 divided by 3 is 0. 1 is less than 0 is a false statement. 1 is greater than 0. So since that's false, since I got a false statement with my test point, I'm going to highlight the other side that does not have 0, 1. And if I grab the test point on this region, like if I grabbed 1, 0, let's say, like what if I grab that point, like 1, 0, you get this, you'll just get a true statement. So if I did grab 1, 0, since this is pretty straightforward, this is 0 less than 1/3, 0 less than 1/3, that is true. So that's why I'm highlighting this side with that test point. So underneath the line for this one. And again, there is a way to just look at the inequality and be able to know which sides you're highlighting on. I typically don't like to like lead with that because it is a little confusing. So if you look at this one, y is less than x over 3. So since y is less than x over 3, you want less than the values below the line. So here's our line right here. So we want all the values below. So here's our line. We want all the values below. Then if I go back to these other ones, this one was y is less than negative x over x plus 6. So less than, so here's our line. So then we highlight underneath because we want less than. Then here, this was y is less than or equal to 3x minus 2. So here is our line, and these values would be less than. Not super easy to see right away, but if you're pretty good with that, then it might cut down some of the work. Next, graphing 4x plus 6y is less than or equal to 18. So I'm going to subtract 4x from both sides. I get 6y less than or equal to negative 4x plus 18. Let's divide by 6. Y less than or equal to, and then negative 4 over 6 is going to simplify down to negative 2/3 x. 2 goes into 4 2 times, 2 goes into 6 3 times, plus 18 divided by 6 is 3. So the y-intercept is 3, and then my slope is negative 2 over 3, so that's going to go down 2, so negative 2/3 is down 2 to the right 3. So down 2 to the right 3, down 2 to the right 3, or up 2 to the left 3. And that is going to be a solid line, less than or equal to, solid line. And let's highlight. We want to highlight the side that is less than, so I'm going to highlight underneath. And if you grab a test point, you can grab 0 0, perfectly fine test point. Let's just do that real fast. So if I grab the test point of 0 0, that's going to be 0 less than or equal to negative 2/3 times 0 is 0. 0 less than or equal to 3. 0 is less than or equal to 3, so that's true. So that's why I am highlighting the side with 0 0. The last two for this video, and then I'll make a part 2 with the actual systems. So graphing y is greater than 2. So we're going back to the discussion of something like y is equal to 2, then number 6 is x is less than 1. So going back to what is the line of y is equal to a constant, x is equal to a constant, what do those lines look like? So y is equal to 2. If you remember that, that is going to be a horizontal line at the value of 2. So it's going to be horizontal. The value, oops, I didn't mean to do that. But we're going to have a dotted line because it's strictly greater than, so I'm going to put a dotted line. Didn't mean to put a solid line there. I was just graphing y is equal to 2, not thinking. So there's our dotted line. And we want all the values greater than 2. All the values greater. So what order pairs would make this a true statement? Well, if you think about it, it's any y value that is greater than 2. Like if you take 0 0, for example, like if you try to test out 0 0, all you're going to have is 0 is greater than 2. That's not true. So then you'd have to highlight the other side. But if you just think about it from a more logical standpoint, I want all the values greater than 2, all the y values that were greater than 2. So what are all the y values greater than 2? Up there. So any sort of order pair up above the line. So like 2 3, 2 4, 2 5, 4 8, 4 9. Any order pair with a y value that is in this region will give you a true statement. And then for x is less than 1, so the x value of 1, this is strictly less than, so that's going to be a dotted line. And we want all the values less than 1, so that means we want to highlight left, because we want all the x values that are less than 1. So what are the x values less than 1? There's 0, negative 1, negative 2, negative 3. So all of these potential order pairs over here are going to be less than 1.